Good afternoon, class. So we'll continue from where we stopped last week. Last week we spoke about uh, various things to consider in terms of practice and what to consider in terms of practice and development. So we're still on chapter 4, and we'll consider principles that guide practice and principles that guide process. And we started all of that. We spoke about practice, practice principles, process principles. We spoke about communication principles and the likes. So today we continue with modeling principles. What are things to consider when we are modeling? So modeling can be divided into requirements modeling and design modeling. That means we can design, we can model the requirements, and we can model the design. What is always common is to actually model the design, but I can assure you now that currently design modeling is very key in today's software engineering process. So now in requirements modeling, requirement models represent the customer requirements by depicting the software in 3 different domains. Now there are 3 different domains in requirements modeling. First is the information domain, which deals basically with the information. What information is needed for this software that is being developed. Then we have the functional domain. Now the functional domain has to do with the functions of this software. Of course, you know that we've spoken about this many times, that you have to divide the app or the software into various sections, various components. Now you can either talk of the function of each of the components, and you can then model the system based on that function, based on the functional domain. Then we have the behavior domain. Now, of course, we've talked about behavior also, and I define behavior as how a system responds to external stimuli. Now, of course, we also need to model the behavior of the system. If, for example, how is the system supposed to behave if a user puts in wrong input? That should be part of our model. What if somebody tries to log in to an account with various types of user access data types? For example, you can have email address, you can have phone numbers, all those kind of things. Now, you must be able to model all of that under the behavior of the system. Then we also have design models. Now, design models represent characteristics of the software that help practitioners to construct it effectively. Now, the design models can be divided also into 3. First is the architecture. As a matter of fact, is always the system architecture that is always the first point of call in design. When it comes, that's design models. In terms of design models, even in your project, one of the things that you are expected to demonstrate is the architecture of your system. You want to see how it is laid out on a broad level. Then we have the user interface. Most people do this actually, especially those in mobile development. They try to model the interface, trying to see what is first way supposed to look like before they start developing. It's a very common practice. Then we have the component level detail. Now, of course, you can tie this component level detail to the functional domain of the requirements. But at this point, you are talking about the functionality of the design. You're not talking about just the basic information, or this is supposed to do, or that's what it's supposed to do. But you are talking about how to design the component, the entire component. What is how it's supposed to appear? What are the various things you need to actually to make it work, maybe perform the function that it's supposed to perform. That's what we talk about under design models. Now, requirement model. Okay, I think I've actually explained this from the previous slide, but these are just the formal principles that guide it. But of course, everything I've said, one way or the other, we still find this in here. Information domain of a problem must be represented and understood. The functions that the software performs, but of course that's what we're talking about under the functions. Then the behavior of the software. Like I said, as because the consequence of external events must be represented. Then the models that depict information, function, behavior must be partitioned in such a manner that it uncovers detail in a layered fashion. Now they are talking about the hierarchical version again, that you just it's almost even impossible to actually want to design a system and you want to model it and you model the entire system just on one just at once. I mean, that's not even going to work. You're supposed to have it layered, hierarchical. Of course, I personally would prefer from to a workflow of how the system functions. That's the method by which you can have an hierarchical or layered fashion of requirement modeling. Then the principle 5, the analysis stack should move away from essential information towards implementation detail. Now, not just like that's what I was saying again, other requirements gathering, that is more than just, oh, we need this app, and what this app is to do is this, and then from this we need this kind of information. There are a lot of things that will miss out. That's why scenario kind of model requirements gathering is the best. Then again, design modeling. Again, I've explained this when I was talking about it generally, but we can also still talk about it here. Design should be traceable to requirements model. I mean, that's what we still talked about in requirements testing. Now, whatever it is you've designed, you must be able to tie it to what you set out to do. Always consider the architecture of the system to be built. Design of data is as important as design of the processing functions. Most people make this mistake. All they want to do is just to model the functions, model the workflow, and start moving. But the data too should be modeled. How is this data supposed to be represented? What kind of data are you dealing with? That is very, 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 very important. I mean, there are a lot of stories that are around when people model data improperly. Of course, the popular one I usually give is that of YouTube. YouTube crashed around 2009 because of wrong data modeling. They defined their views. They never thought that a time will come when they will have 1 billion views for a video. And Gangnam Style was the first video that broke that record. And because they didn't model very appropriately, YouTube crashed because of that 1 billion views. So it's always good to model data appropriately. Then user interface design should be tuned to the needs of the end user. However, in every case, stress ease of use. Now again, another example I remember I gave to you guys is that whatever it is you are designing, people want to see like an electronic version of what they are used to doing. That is only when your app will make sense. When if for your portal, like I don't know if it was a class, I was giving the example of your portal where you want to go to online to take a class, and now you now imagine that you've taken the class before you register for the course, which is not what you guys are used to normally. You guys will even complain. The normal thing physically is, you come in, you register for the course, you're admitted into the class, you take the class, you take the exam, of course. So even now, when they now want to design such a system, when they want to turn it to your electronic learning SSO and the likes, it just makes sense to just mimic that what you've always done physically, and they just turn it electronically like that. That's when you will be able to relate. Otherwise, a number of projects, a number of software apps have been thrown into the bush because of that, when it doesn't just flow with what people are used to doing ordinarily. Then component level design should be formally independent. Of course, we've always talked about it. It's like our component level, the functionality, when you're talking about the function of the system, should be designed on a functional basis. Then components should be loosely coupled together and to the external environment. Of course, we said loosely coupled, we didn't say lightly coupled, because at the point you still need to make other components will still have to relate to this particular component. So you don't want to lock it up and make it just be on its own, not an entire system on its own, just a component within a system. So that's why it has to be loosely coupled and not tightly coupled. Then design representations should be easily understandable. Of course, that is quite clear. The design should be developed iteratively. With each iteration, the designer should strive for greater simplicity. The primary goal, agile modeling principles. Of course, we've talked about the traditional principles, and so as I was saying, we've spoken about the conventional modeling principles and agile modeling principles. In terms of modeling, now let's see how agile plugs into your system in terms of modeling. Now, the primary goal of the software team is to build the software and not to create models. At the end of the day, what you are developing is still your system. Models are also only supposed to guide you in doing that. Travel light. Don't create more models than you need, and you don't create unnecessary trouble for yourself. Strive to produce the simplest model that will describe the problem or the software. Build models in a way that makes them amenable to change. I've stressed it more in this class that plans change. Till you will finish your project, you will always need to change plans. Either in terms of technically, in terms of how you hope to implement something, there will always be something to change. Either in terms of your testing platform, there will always be something to change. But even in terms of cost, well, that is if your clients agree to that, though, because that's totally not true. But obviously, what I'm just trying to say is that plans will always change. Be able to state an explicit purpose for each model that is created. Adapt the models you develop to the system as hand. Try to build models, but forget about building perfect model. Of course, it can't be the perfect model. So just try to build models that will try and represent or mimic the system you're trying to develop. Don't become dogmatic about syntax of the model. We've always said again, one of the things Agile tries to give to you. Don't be dogmatic. Don't be stereotyped. If it communicates concept successfully, representation is secondary. If your instincts tell you a model isn't right, even though it seems okay on paper, you probably have reason to be concerned about. You must have a level of experience before you can get to this point. It was when you've done something over and over and over, that's when you have a third sense, so a fifth sense about being able to pick up problems, even if those kind of problems were not so pronounced. Then get feedback as soon as you can. That's one of the mistakes some of us usually make. We always want to wait to have this very robust application that is functioning perfectly before we go to show the owners of the software that that is actually not so good. Because what if you at some point at the earlier at the infancy stage you made a mistake and you propagated that mistake till you have this your full-fledged application, and by the time you're now showing to your to the owners of the software or the app, they're not tell you made a fundamental error. That would now mean that you have to edit everything from the initial point back. So that's not a good. Always at regular intervals, get feedback. It will save you a lot of trouble. So now, construction principles. Construction activity encompasses a set of coding tasks that lead to operational software that is ready for delivery to end or to the customer or end users. Coding principles concepts are closely aligned programming style, programming languages, and programming methods. Testing principles and concepts lead to design of tests that systematically uncover different classes of errors, and to do so with a minimum amount of time and effort. Of course, I've always said it that is at the time before you start coding, you must have your tests ready, your test principles of what you want to test. You must have it. It's not at the end of the coding. It's not at the end of the coding that you want to start testing. Before you say, how do you then know if you made mistake? Before you even start at all, you must have your testing plan ready. That's why we always also talk about coding together with testing. I'll post this video here, then we'll continue in the next video. Thank you.